Welcome back Year 12s to the next video. What you can see is we're going to be looking at reducing balance loans again in this video. However, we're going to be looking at a particular case where we are changing the conditions, or a few cases in fact. So changing conditions just means that you might have something like an interest rate change. You might have someone increasing or decreasing the payments that they're able to make on that loan. You might even be wanting to change, say, the loan duration. So there might be changes then that happen to payments. So lots of different things that you can change, obviously, in your loan because there's lots of variables in a loan. But what we're going to do is have a look at how we calculate these and also just some of the overarching ideas of what happens when certain things change in a loan. To start off with, I've got this example here where we've got a house being purchased. And in this one, there are a couple of, one in particular, a key term that you might come across when you are looking at mortgages. So this one is very similar to one that you're going to come across in your chapter questions. So keep that in mind. You might come across someone like this and you might want to then come back to this example to have a look at what we did. So we've got a couple putting down a $70,000 down payment. Now a down payment is another word for it is a deposit. So when you buy something as large as a house, you'll generally not be able to front up the funds, all of the funds for that house. We know they're very expensive when you purchase it. So what's expected is that you'll pay a small portion of that house. Now, generally it's 10, sometimes 20% that the bank will require you to have of the full purchase, but it can differ greatly depending on the circumstances. So down payment is a deposit. It's basically your security. You're securing that purchase so that obviously the person owning the house and selling it has got a guarantee from you that you are committed to that purchase. So this couple have given their deposit up when they bought the house, the $70,000, but obviously the house would have been a lot more expensive than that. And so the rest of what they owe is going to be taken out as a loan. So you'll see here it says arranges to pay off the rest in monthly payments of 2184 for 30 years at a compound interest rate of 6.5, etc. So that second part there is talking about the rest of the money that they owe for purchasing this house. We're going to write all of our answers correct to the nearest cents. Of course, that means 2 decimal places, as we always do. We're asked first, what was the selling price of the house? Now, we know that they've paid this little bit already, the deposit. What we don't know is what they've had to loan. So we don't know what is the rest of what they've borrowed in order to buy this house. So in terms of, oops, I've just put the question mark in the wrong place. In terms of what they've borrowed, we're essentially asking at the start of the loan, what is this amount? What is it that the bank has given them? What we know is that it's for 30 years and that is compounding monthly. It just says there, monthly compounded rate. So we're looking at 30 years monthly. So 30 by 12, that's going to give us 360. The interest rate, 6.5, we can see that in the question. The payment we can also see as well because it is 2184. Remember, we put that in as negative 2184 since it's being given back to the bank. After these 360 payments, it's paid off, so that will be 12 payments a year, compounding monthly. Now, when we do that, remember what it's going to give us is what they borrowed. So in your calculator, you should get 345,532, and rounding that to 2 decimal places, 0.43. Now, if we just left it like that, unfortunately, we wouldn't get the full marks because we were actually asked about the selling price of the house, not what these people had to borrow from the bank, but what that house cost them altogether. So selling price must include that deposit that they also put down, which was up here, the $70,000. So we're taking our amount borrowed from the bank. This is what they couldn't put onto or couldn't give straight away, plus the bit that they did give. And we see that they have spent on this house 415,532.43. So a very specific figure. But you can consider as well, when you buy a house, there's lots of different charges that come along with it. So that might explain all these funny numbers here. So 415,000 approximately, just over. We want to know next how much interest will they pay over the term of that loan. Now, this is where I've had students in the past be quite surprised in a 30-year mortgage, particularly at a rate as high as 6.5%. Keep in mind rates at the moment are less than 4%, so this is quite high. Keep in mind that you're talking about a very large sum of money, 415,000, pretty decent rate, 6.5%, but also this is a really long time to pay off that money, so 30 years. Now, since you're paying interest on that money over 30 years, don't be alarmed when you see the amount of interest that this couple is going to be paying. So, how much interest will they pay? How do we do it? Well, we want to know the total cost of that loan. And we do that by multiplying their payment by the number of payments. What we'll do then is we'll take away what they borrowed initially. So we see how much they give back to the bank, how much was loaned to them to begin with. So we've got 360 payments of 2,184, and then we're taking away the amount borrowed. I've just put the selling price, but of course we actually just want the amount that they borrowed up here, 345,532, because they don't pay interest on that $70,000. That's not included here. Okay, so don't fall off your chair, but if you have a look, yes, you're reading this correctly. $440,707.57. So obviously the reason most students are quite alarmed by this when you do this calculation is if you have a look at what they bought the house for to begin with, the house only cost them $415,000. If they had that money up front, they would buy the house for that. Now, as you can see, since they had to borrow so much, they had to borrow $345,000 and pay interest on that for 30 years, for 3 decades, they're spending $440,000 extra on the house. So as you can see, they're spending actually over $800,000 on this house altogether. Now, this is pretty normal, especially given house prices these days, which are substantial, and the inability of a lot of people to front up a very large deposit means that people are borrowing a lot more money, and it means that over time, especially with a long loan period like this, you are spending a lot on that asset over time. Now, one of the upsides is that asset might increase in value, of course. We've seen that happen in the last couple of decades. House prices basically doubled. But there's also a big element of risk in there as well, because that may not happen. So a lot of interest, but it's their home. So some might argue it's worth it. How much do they owe after 5 years? Okay, there's a reason we've been asked to do this, because if you read ahead, you'll see that after 5 years, there's going to be a change to this loan. So first, let's just work out after 5 years. All we have to do here, because we've got all the info in our calculator already, we just need to change N to 5 years monthly. So we need to change N to 60. Once we change N to 60, we're trying to find amount owing, so we're trying to find FV. And if you do that in your calculator, you'll get a negative value. That means they still owe the money, and you'll see that after 5 years, they haven't actually paid much off their loan. Now, that's expected because at the beginning of the loan, that's when you're paying the most interest, because you owe the most at the beginning. So it's only 5 years old, this loan. They still owe a lot, $323,456.28. So just I don't want to leave my answer as negative. They owe, and I also want to put the dollar sign in as well. 323,456.28. Okay, so let's get into the good stuff. So what happens when we have a change? As you can see, after 5 years, the bank actually increases the interest rate. It's going to go up by 0.9%. And you'll see it says the couple now must now extend the period of their loan in order to pay it back in full. So really two things can happen here. If the interest rate goes up, that means that your payment that you're making is now not going to pay off that loan in the same time period that you first took out that loan. So basically the 30-year period that they initially made, they're not going to pay that off if they keep paying their 2184, which is what their monthly payment was. So what we're going to first look at is how much are they actually still going to owe? If they just keep paying the 2184, what happens at the end of that 30 years, considering that the interest was being charged at a higher rate? Keep in mind this wouldn't actually happen with the bank. When an interest rate goes up, they will make you pay more on your payment just so that you do pay it off in that original loan term. They don't want you getting to 80 years old and still owing money on your house. They want you to still pay it off in that time period. Okay, so what do? Now, if you have a look, we actually have found already how much was owing after those 5 years. The trick with these sorts of questions is you have to imagine that the loan has sort of stopped. So when this change happens, it's after 5 years, imagine there's a stop to the loan and you're going to start that loan again with the new rate. So what I mean by that is this bit that they owe, the $323,000, I'm going to put that as PV. Keep in mind we can call it this the start and the end. So I'm starting this loan again just so that I can use this new rate. So I'm going to put the start of this second period of the loan, which is essentially the last 25 years, in here. Now it has to be positive because you're imagining you're starting the loan from the beginning. So this is money that was given to them. We now have, since 60 payments have passed, so 5 years of pay that have passed, we are left with 300 payments until the end of the loan. And their payment before was 2184. This will all still be in your calculator, most of it. And we've got down here what we're finding, what they owe after that point. So 12 and 12. Now, this value here, this was probably in your FV. So it was sitting down here because we just found it for this previous question. Now, what you can do, what I find much easier is actually just copying. So once you've got that highlighted on your calculator, you can press Control C and then you can bring it up to this cell and press Control V to paste. So it's, if you want to write that down, Control C to copy when it's highlighted and Control V to paste. So it's the same as on a regular keyboard, of course. Might just put that little box around there. Now, I might show you that with the next example just so you do see a visual of it. So this is the rest of the loan. The rest. So we're starting 5 years in, start value of 323,456. Our rate went up by 0.9, so it was 6.5 plus 0.9. That's where I got the 7.4 from. And then we go down to FV and we're going to see they still owe. This is what a big difference an interest rate change can make. We have a look there. They kept paying that money, that 2184. At the end of their loan, they actually still have all of this to go. Because essentially what would have been happening was each payment that they're making of the 2184, more of it's going to interest now than should be going to interest because the rate went up. Less of it is then being paid off the loan. And as a result, that's obviously compounding. It means that at the end, we still have all of this money left. Now, we don't want that. The bank doesn't want that either because you never pay it off. Or you won't be in a position to be able to pay it off because you would have retired. So what we want to do is make sure that people do pay off their loans in those original time periods. And so what we're going to do is calculate the monthly payment that this couple need to make if they do want to pay it off in full. So some of these things will stay the same: 300, 7.4, this positive 323, 456. That was the amount owing after 5 years. The payment is what we're finding now. If your interest rate goes up, that means your payment per compounding period is also going to go up. And that has to happen if you are going to pay it off in that same time period. So when we do that, we will solve for payment. We get 2369.3135. We'll round that off, put our final answer at the bottom here, 2369.31. So as you can see, their payment, it went from 2,184 up to 2,369.31 per month. So just under $200 extra that this couple need to find to be able to cover their mortgage repayments. So that's why interest rates, they get a lot of attention in the media. The last few years, though, our interest rates have been at historical lows. They've been very low. They haven't really moved much, not in the last 3 years at least. And there's talk of them even dropping more recently. So when you are watching the news or reading the news and you see interest rates, maybe now you'll have a little bit of an appreciation as to why it does matter to so many people, anyone with a mortgage. Okay, just a second example now. We've got Phil with an $85,000 loan, 6.6% per annum, and monthly payments are given. How long is it going to take him to pay off this loan? All right, let's get the info in. 6.6, we've got 85,000. That's given to him, so positive. What have we got? Negative 2019.69 is his payment. I've placed it as negative. It's going to the bank. He's going to pay it off. It is monthly, so it's compounding monthly as well. And what we're going to do is solve for n. Now, I might do this one quickly on the calculator so that I can show you just that copy and paste function. So we've got 6.6, 85,000, negative 2, 9 point. Okay. And we go up here and press enter. So as you can see, 48 payments. So it's come out quite nicely. 48.00, etc. So we'll be rounding that off. It's 48 payments, which is 48 months. And of course, we divide that by 12 for years. We get 4 years exactly. Okay, now what's happening? 2 years into the loan, Phil's going to renegotiate, he's going to refinance, and he's going to make sure that he can have it fully repaid a year later. 2 years in, he's going to pay it off a year after that. So 3 years in total. Remember, keep in mind he originally was going to take 4 years. So he's going to wipe a year off of this loan. Okay, the interest rate will remain, so that's important. What's his new monthly repayment going to be? So already I'm thinking if he wants to pay it off faster, he has to pay more. He has to pay more because he's basically paying an extra year's worth of payments in a shorter time period. Luckily for Phil, one of the reasons he's probably going to do this is because it will save him interest. So he'll pay extra in terms of per month, but he will save interest if he does this. So this is what a lot of people aim to do with their mortgages. They try to make extra repayments because that will allow them to pay that loan off a lot faster and save them sometimes hundreds of thousands of dollars. So what I wanted to do is show you how I do this on the calculator, but also this is what is going on in my mind. So this is what I envisage every time I come across a changing condition. In the calculator, we have this first part that we've done, and that is that at the beginning of the loan, he owed 85,000, and 2 years into the loan agreement is when the change happens. So this part here represents 2 years, or since it's monthly, that's 24 payments. The loan is going to change here, so after 2 years, and we're told that it's 1 year later that he wants to have it paid off. So that means this last part of the loan is 1 year in duration, which is 12 payments. So I've just broken it into 2 parts. Now what we need to know, to be able to do this second calculation, we need to know where his loan is at the start of that final year of his loan. To do that, I need to know where was his loan at the end of these first 2 years of payments. And that's where I'm going to start off with, and you'll see that written in the box here. It has to be approached in 2 parts. You have to break it into 2. First of all, we need to know how much is owing after 2 years, because we can't do anything until we know that, where the loan changes. So we're talking about 24 payments at 6.6% interest, $85,000. This was his payment. We were given that in part 1 of the question. It's 12 and 12. So we want to know this bit here. Now, I've got that in my calculator over here. We found that it was 48 payments to pay it off, but I want to know in 24 payments, how much is owing? And there we have it, 45293.3756. Now we will we'll leave that. We won't round it off because we're partway through the question. So 45293.3756. So just, you've got that value in your calculator. I'm just going to make a note on the side. So he owes 45293. Now often these questions are actually broken up in 2 parts for you, just like the one we did previously with a couple buying that house. They did actually ask us how much they owed after 5 years. Okay, the next part. Treat the rest of the loan now as a separate new loan, because our financial solver will require us to do that. So we're going to use the amount owing up here as the start of this next period of the loan. So start and end down here. Now keep in mind he wants to pay it off, so our end is going to be 0. 1212 is the same, and we have the interest rate staying the same as well. So we've got that happening. Keep in mind what we are finding. We're finding here PMT, the payment. How much is it going to have to pay to ensure it's paid off in 1 more year? 1 more year represents 12 more payments. Now, this is the copy and paste part. We know what was owing before. It was 45,293. We need to get that value into PV. So what I do is you'll see once you've pressed enter, it highlights it automatically. If we press Control and then C, that should copy that value for you. And then we will just tab down to PV and we'll press Control and V. And notice it's brought the value up there for me. The issue, of course, is that this value is negative. You'll see it right back here, this tiny little negative. I don't want it to be negative because the start of a loan represents the bank giving you that money. So if it's negative, we've got the wrong, transaction taking place. That would be Phil giving that money to the bank, not the bank loaning that money to him, which is what happens with a loan. So what you can do, slow way. Slow way is to scroll all the way back and take out the negative. Fast way is once you've got the value there, if you want to change the sign, the easiest way to do that is multiply it by -1. Multiplying by -1, I'm pressing tab, multiplying by -1 is your fastest way to change a number from positive to negative or negative to positive. And so I find that's a lot quicker. There's less scrolling on the calculator. Just times it by -1 to change its sign. I'll go down here, change that to 0 because that's what we wanted. And I need to change N because we've only want 12 more payments. And it's PMT that I'm going to solve for. So I just need to press enter. We saw the payment go up. That was expected. It went up by a lot as well. It was just over $2,000 before, and now it's almost $4,000. So 3910.74. Let's go back to this screen here. We want that positive, and it was 45293.3756. So that I'll just put a little arrow to there to show what we've done, and also might just pop a little thing around that because that's really important that we change the sign. Our payment that came out was like this. It's negative because it's going to the bank, 39107412 ... So the new payment is 3910.74 rounded to 2 decimal places, and that's to ensure the loan is fully paid after total of 3 years. Okay, so just to summarize, just a couple of points. We used Control C, I know we wrote this before, to copy, and we did Control V to paste. And my second point was times by -1 to change the sign. I find that is the most efficient way to do it. Just one more thing to show you. I know these questions are quite substantial. When we are doing reducing balance loans, quite often our final payment is a tiny bit different to the payment we've been making throughout the loan. Now that's because of rounding generally. So when the bank calculates your payment that you need to give them, they do need to round that payment off because you can't be paying them an amount to say 6 or 7 decimal places. That doesn't make any sense. So they will round your payment, but as a result, over 30 years, that might then change that tiny, just by a small amount, the last payment that you pay back. So this is actually a past exam question I'm going to show you now. And I'll try and make it as clear as possible what we do in terms of finding the last payment, the final payment. So we've got Leslie, $35,000 was borrowed from the bank. Interest is charged, there it is there. 47 payments are going to be made, and then the last payment's going to be adjusted. So when they say that, they mean interest is going to be added. It's going to be adjusted, so it'll be fully repaid. Well, that's really the main reason that it's adjusted, I should say. It's fully repaid with interest added. So after 48 altogether. Now, it says here, what is the final payment? Now, looking at the answers, I'm thinking it's probably not that one because that would be exactly the same as the other payments, and that wouldn't make much sense. So just keep in mind, sometimes there'll be some I guess, random answers given to you. If we have a look down here, we first want to find how much is owing after 47 payments, because essentially after 47 payments, you've got a bit left over. Interest is going to be added to that last little bit, and then it's going to be paid off. So basically what you want to do is the second last payment, because this 47 is only applicable to this question. So look for your second last payment. So 47 at a rate of 4.75. The loan was 35,000. That's positive. Payment was 802 exactly. And then we've got 12. So we're trying to find how much is owing. When you do that, what you'll notice is it's a little bit more than the $802. So it means that this last payment couldn't have been $802 because there's this little bit left over after that. So after 47 payments, we owe 802, oops, 3911, etc. You'll notice that 802.39 is also on the list up there. Now, the issue is that amount owing there, you aren't going to pay that back until the next payment, which it was monthly. So the next month you're going to pay that back. Now, you are still being charged interest on that amount. So the following month comes along, you don't owe $802.39 because remember, we're always charged interest on the balance. So you're always charged a percent of the balance. So what I know straight away is that this can't be the final payment. The final payment has to be a little bit higher than this. And if you have a look over here, there's actually only one value that's higher than this last balance of the loan, and that's this one. So I know that has to be the answer. If I was short on time and I didn't have time to actually calculate it, I would circle that one. To show how we get $805.57, however, I'm going to show you how we add the interest on. Now, we've done this with an amortization table. Interest is 4.75% per annum, but it's monthly, so divided by 12. That's a percentage, so it's over 100, and the balance was 802.3911, etc. That gives me 3.17613, or if we round that, 318. So you charged an extra $3.18. I won't round it off just yet, actually. But that's just an idea. That's just a tiny little bit more. Final payment. Final PMT. We had 802.3911 plus our 3.17613, etc. And grand total, as expected, 805.57, which is E. So that's how it's done. You're just doing exactly what we did with an amortization table, percent of the balance. And since we want the balance to be paid off, we've added that interest onto the balance, and that is now the final amount owing. So it's a bit extra because interest has to be charged on that last little bit. Okay, I'll finish there. There are some questions for you to have a go at with the changing conditions. This is probably one of the most challenging parts of our financial mathematics unit. So just keep that in mind if you are finding this challenging. It's not a surprise at all to me because it is complicated. But the practice, and keep communicating with me as well where I can help you, just so that we can maximize, our achievement with this.